As far as the discussion, I mean, I think this one's quite simple, and I'll try and go through this quicker. As always, folks, whenever you have a mechanism that we have taken up in class or is in McMurray or is very, very well known, and there's nothing terribly difficult about it, you should always have the mechanism written. You should always then write down a reaction energy diagram. Now, obviously, if we're looking at ammonia doing the attacking and chlorine leaving with a hydrogen, right? You know, I didn't even bother writing in the ammonium hydroxide. The one thing that's crystal clear about this reaction, acid chlorides are literally one of the most reactive organic functional groups known to man. Amide functional groups are one of the least reactive, so clear as day as far as the organic functional groups are concerned. Clear as day, this should be very exothermic. And it turns out that it obviously was. You add a little bit of ammonia, you can even hear it popping when you add it, giving off a lot of heat. So it's obviously exothermic. Whether or not we can think of this as being an intermediate, don't know for sure. I chose to just write it as a simple reaction energy diagram. Very exothermic, and the fact that yes, you did observe some heat, so we know that for a fact. The other interesting side reaction here is we know we can smell it. You can smell ammonia coming right out of what you're adding to it. It's ammonium hydroxide, but it's 33% ammonia gas. So there's ammonia gas all around. The fact, this is an observation, the fact that we end up with white solid powder on the thermometer on the side of the flask above the solution, and you can see it almost like a white smoke or mist, you can't say that the HCl from the reaction is all staying just in solution. Obviously, you're getting some gas reacting with the gas of ammonia to cause the solid ammonium chloride to form outside of the solution. I mean, that's a fact. There's nothing else that's actually associated with the reaction at all. So the only thing it can be is ammonium chloride, and the fact that it's out of solution means it had to have in gas form. So that's an interesting discussion point. As far as the percent yield, one of the things is the product is extremely soluble in water. So one of the things that we could do is, if it's that soluble and we want to double check our yield, we might, if we could, run an HPLC on the aqueous layer just to see how much of it is still left in the water layer. So however much mass you think you weighed, it's possible that it should be higher because it's left out in the aqueous layer. The other problem that has to be mentioned, folks, the previous experiment, almost every single one of them, the weight or the mass that you think you started with of the chloride, it can't be right, because there's so much thionyl chloride that essentially everybody has co-distilling in the previous experiment, right? So for every student, it's going to be happening to varying amounts. So the only way that we could really try to accurately make sure that our percent yield is correct, you'd have to do an HPLC of your starting material to confirm how much is actually in the liquid that you added to the ammonium hydroxide, right? So folks, long story short, this is one experiment where your percent yield that you're writing down as a number is almost completely useless, right? As far as the percent yield of what you should have got. We can correctly weigh out how much white solid product we got, but as a percent yield, that's not the same thing. So feel free to write any extra discussion points that you can think of for this one. I mean, as you're noticing, as we get closer to the end of the semester, I might start shortening these up, trying to see if you guys can start applying what we've been doing in the discussions by yourself. Debatable whether in Organic 3 any of these types of discussion videos will be had. Maybe not the discussion so much. Maybe I'll still continue some IR, NMR, but we'll have to wait till fall and see how we do that.